Hey folks, I'm Mr. Rose, as you know, and today we're going to go on to recording number 2 about our vector diagrams. Just a quick recap from video number 1. We know a vector is a representation of a unit in physics, or dimensions in physics rather, that have both tails and tips of arrows, and they represent a size and a direction. Here I gave a little example of a sketch where I had a 3 meter per second velocity and a 2 meter per second velocity in the same direction. We know we add them. And here underneath, I did not write this in the last video, but I showed that the order doesn't actually matter. If the 3 and the 2 or the 2 and 3, it doesn't matter because the resultant in the middle is still 5 meters per second east. Then we did a quick little to scale diagram where I did everything to scale and I used the protractor and a ruler to measure. Now I have a more complex scenario of 3 different directions. So we have a person that runs 5 kilometers north. They turn 25 degrees west of north. We'll explain what that means. They run 8 kilometers, and then they turn 55 degrees south of east and run another 10 kilometers. So this one, we're going to do a scaled diagram, and then video number 3, we're going to do it mathematically because there are 2 ways to do it. So here I'm going to start by defining my scale. I'm going to say that 1 centimeter equals 1 kilometer. It's just nice and easy. Now, I don't know exactly which way this is going to go, so I'm just going to start right in the middle with my x. And I'm going to look at my first set of directions. Now, you should pause and look at this so you can write down all the detailed information because I'm going to keep taking this off of the screen. But my first direction is 5 kilometers due north. So I take my ruler and I'm going straight 5 kilometers, which in this case with my scale is 5 centimeters. And I label 5 kilometers due north. I then take my protractor. I know I'm going to turn 25 degrees west of north. So what that means is I ended. If I was really on this journey, I ended right there. So I'm right there. I take out my little compass. I'm like, oh, what does that mean? It means I'm going to turn 25 degrees west from my north point. So there's my north. I take my protractor, and the way I use it, I put the little dot or the circle right in the middle to make sure that it's nice and it's going straight with that line. It's going straight with my 90 degrees. And I'm going to count 25 degrees. Now, again, on this protractor, I can use these inside numbers if I want, or I can just count 10, 25. So there is my 25 degree mark. You can see it up there. I now take my ruler, and it's 8 kilometers. You can see right there, 8 kilometers. So that means I need an 8 centimeter line, which just barely fits on my paper. Look at that. That was a lucky accident. Oh, I missed. I'm sorry. I'm going to try that again. Right there. And wow. Just barely fit. So that was a lucky coincidence where I started my paper. Now I know, sorry, I'm going to ignore that line here. I know that this angle that I put in here, that was 25 degrees. And that what it really means is, like I said, it is west of north. So there was my north line. And I went 25 degrees west and I ended up there. Now my last bit, it was 3 different turns. I then stopped for coffee and I turned 55 degrees south of east. So it's going to be harder for me to put my little compass right there, but I know I only need the south line, or my south and my east line. So west, east, and if I forget that, I'm going to put that right here. North, south, west, east. So I'm going to come off of that 55 degrees. So I take my protractor this time. So before I held it this way, now I'm going to show you that you can do it both ways. So I'm holding my protractor like that. And I'm counting 55 degrees into that direction. So starting here at that 0, 10, 20, 30, 40, 50, 5 degrees. So my line needs to come off of that. And it's 10 kilometers. So with my scale, it is 10 centimeters. So I need to get all the way to there. From there, all the way to my 10 centimeter mark. Put my vector. Label this 10 kilometers. That was 8 kilometers. And then this angle was 55 degrees. Now, the reason we draw things to scale, again, each one of these parts, that was my component, so I could see right away my distance, 5, 15, 25, 24, 23. My distance was 23 meters. That's just a scalar. My displacement, delta x, is the distance from start to finish. So my resultant vector, I draw from my starting point to my ending point. That right there, I'm just going to label R for my resultant vector. Now that resultant is, it's nice and easy. Because I have this scale, I just take my ruler and I measure it. And I see that it is 4.7 centimeters. This was about 4.7 centimeters. Based on my scale, my displacement is 4.7 kilometers because every centimeter represents one. Oh, that's meters. That should say kilometers. 1 kilometer. Now, that is still not a displacement because a displacement has a definite size and direction. So for my direction, we're always going from the starting point. So again, that would be my starting point. There's my little compass, north, south, west, east. Take my protractor. Again, I can hold it either this way. So I have that on my x-axis, that on my y-axis. Or I can hold it this way, such that I have this on my x-axis and that on my y-axis. And now I'm literally just going to count 10, 20, 30, 40, 50. It looks like about 60 or 61 degrees. So this right here is about 60. If I wanted to do it this way, I can show you again. Oh, it is definitely a little past the 60. It is like 60 or 61 degrees. I'm just going to say 60 degrees. So it's at 60 degrees. But now, again, in math, again, us math and physicists, we can always go all the way to 360. So technically, 60 degrees from the x-axis would be fine. If I was over here, I could keep going like 120 degrees from the x-axis. Or if you're talking to everyday people, it would be 60 degrees. This would be north from east. North from east. That is all I have with drawing things to scale. In video number 3, we're going to pick right up and we're going to say, hey, what if I wanted to do this just with sketches? Because I don't have any of my rulers and my protractors. Thanks for watching, and you'll see me again next time you watch a video.